Solving nonlinear systems of equations. Solve the following system. So if I were to graph this first equation, I would get a center. I would get a circle centered at the origin with the radius of √2. And this equation is a line. So the possible outcomes would be that the circle does not intersect the line, which would be no solution. The circle intersects the line at one point, which would be one solution, or the line goes through the circle at 2 points, which would be two solutions. So those are my possibilities for such a system. If I write these two equations side by side, x plus y equals 2, and then x squared plus y squared is equal to 2. You could do substitution or elimination to solve this system. Since the bottom equation does not have any squared terms, I'm going to do substitution. So I'm going to solve the first equation for y. Y equals 2 minus x. I'm going to take this equation for y and substitute it in to y into the second equation. So x squared plus quantity 2 minus x squared is equal to 2. Now I'm going to solve for x. If I FOIL this out, I get x squared plus 4 minus 4x plus x squared is equal to 2. Now I have a quadratic. I'm going to combine like terms on the left side. So 2x squared minus 4x, and I'm going to subtract 2 also to get it equal to 0. Now if I factor out a 2, I'm left with x squared minus 2x plus 1. And this will factor into x minus 1 times another x minus 1. So if I set each factor to 0, 2 doesn't equal 0. So x minus 1 is 0, which means x is equal to 1. So I have one value for x. If I plug it in for y, y is equal to 2 minus 1, so y is equal to 1. I'll use this equation since y is already by itself. So my solution is 1, 1. That means this circle intersects the line only at 1 point. Solve the equation, or the system of equations, x squared plus y squared equals 5, and x plus y is equal to 3. So again, I'll use substitution. I'll write these two equations side by side. So x plus y is 3, and x squared plus y squared is equal to 5. If I solve for y, on the first equation, y equals 3 minus x. I'm going to substitute this in to y into the second equation. So x squared plus 3 minus x quantity squared is equal to 5. So x squared, if I FOIL this out, 9 minus 6x plus x squared is equal to 5. If I combine like terms and set this equation equal to 0, since it's a quadratic, 2x squared minus 6x plus 4 is equal to 0. If I factor out a 2, x squared minus 3x plus 2 is equal to 0. And this quadratic will factor into x minus 1, x minus 2. And then if I set each factor to 0, I have x equals 1 or x equals 2. So I have two values for x. So if x is 1, and then if x is 2. When x is 1, I'm going to plug it into this equation since y is by itself. So y is equal to 3 minus 1. So y is equal to 2. When x is 2, y is 3 minus 2. So y is 1. So my two solutions are 1, 2, and 2, 1. So these are the 2 points where the line intersects the circle. Solve the system x squared plus y squared is equal to 25, and 12x squared plus 64y squared is equal to 768. So the first equation is a circle centered at the origin with the radius of 5. The bottom equation is an ellipse. So I'm looking for where the circle could intersect some sort of ellipse. I could have 4 points. If the circle is smaller than the ellipse, I would have no points. So I have a couple different possibilities. Since everything is squared, I'm going to do elimination. So I'm going to multiply the top equation by a negative 12 to eliminate x's. So if I multiply the top equation by negative 12, I get negative 12x squared minus 12y squared. 25 times negative 12 is negative 300. The other equation I'll write below it. 12x squared plus 64y squared equals 768. Now when I eliminate these, the x squareds cancel out. So negative 12 plus 64 is 52y squared is equal to 468. If I divide everything by 52, y squared is equal to 9. So y is equal to, if I take a square root of both sides, I get plus or minus 3. So I'm going to write 2 columns. If y is 3, and then if y is negative 3. So I can use any equation. I'll use the top equation. So x squared plus 3 squared is equal to 25. So x squared plus 9 is 25. If I subtract 9, x squared is 16. If I take a square root of both sides, x is plus or minus 4. So when x is 4, y is 3. And when x is negative 4, y is also 3. If I combine those, it will be plus or minus 4, 3. The system may only accept these type of answers and not a combination. So verify it with the online system that you're using. If y is -3, x squared plus -3 squared is 25. So x squared plus 9 is 25. So x squared is 16. So x is again plus or minus 4. So 4, -3, and -4, -3. If I combine those, it would be plus or minus 4, -3. So I have 4 answers altogether. The system may want you to list them like this. So it will only accept those 4 answers. If you combine them, it's plus or minus 4, plus or minus 3. But I will only accept whatever the system will give credit for, which means 2 answers this way and 2 answers this way. So those are my 4 solutions. (9x squared minus 7y squared equals 81, and x squared plus y squared is equal to 9. So on this system, I'm looking for where a hyperbola intersects a circle. I'll do elimination. I'll multiply the bottom equation by 7 to get the y squareds to cancel out. So the top equation stays as is. 9x squared minus 7y squared is 81. And then 7x squared plus 7y squared is equal to 63. If I add these together, the y squareds cancel out. 9x squared plus 7x squared is 16x squared. 81 and 63 is 144. If I divide both sides by 16, x squared is 9. If I take the square root of both sides, x is plus or minus 3. So again, I have 2 answers. If x is -3, or if x is 3. I'll use the bottom equation since it's easier. So -3 squared plus y squared is equal to 9. So 9 plus y squared is 9. If I subtract 9, y squared is 0. So y is equal to 0. So this point is -3, 0. When x is 3, 3 squared plus y squared is 9. So 9 plus y squared is 9. If I subtract 9, y squared is 0. So y is equal to 0. This point is 3, 0. The computer system may want you to list those 2 points. So list those 2 points as -3, 0 and 3, 0. You have 2 answers, plus or minus 3, 0. But make sure to list them if that's how the computer will accept it. Solve the system. X squared plus y squared is equal to 1, and x squared minus y squared is equal to negative 16. And the y squared terms are already opposites. So I'm going to add these two together, and I don't have to multiply them by anything. So I'll do elimination. X squared plus y squared is 1, and x squared minus y squared is negative 16. If I add these together, the y squareds cancel out, so I get 2x squared is equal to negative 15. If I divide both sides by 2, I get x squared is negative 15 halves. Now when I try to take a square root, I end up with imaginary numbers, which means that these two curves do not intersect, so this system has no solution.